Hey, we are viSiONARy, and this is our P3 presentation. So let's first start off with safety, which is very important, as we all know. So what we start off with eye protection. Definitely had eye protection. Now, never touch any exposed wire because that could be dangerous. You could electrocute yourself. Wouldn't be good. We constantly looked after the soldering iron because it was 400 degrees and that would burn you in. So we took our precautions when testing, as everyone should. Now, what is our product main thing? Well, put short, it's really a helping eye.
What materials do we use for the testing? Basically, our physical materials are Arduino Uno, copper wires, breadboard, ultrasonic sensors, and for digital side, we had the Arduino software, or the code itself, and data visualization.
And then for the foundation of our product, it started off at the very bottom with the knowledge and skills we acquired from previous elements, such as finding the problem statements, the criteria, and the overall design we wanted for the product, and then using that to find out the laws and everything that we had to abide by. And then using knowledge and skills, we were able to build our prototype, which is where we made the actual product with everything put together using the knowledge and skills. And then with that prototype, we went into testing where we tested what we wanted and we tried to get the best results as we could. And then we made revisions after that.
Now we're going to get to our process. So it's very started at first with we had to get all the parts to make the prototype. So we sourced them all from Amazon, quick, easy. Then we assembled. We soldered a ultrasonic sensor to a board and connected wires to Arduino Uno. Then for the test, we measured out a 1 foot, 2 foot, and 5 foot. Then we ran a code to see if the piezo buzzer beeped in the correct amount of time at the correct distance.
And then for our bill of materials, it came out to about $31.74 for the cost production of just one prototype. We did have about another $20-$30 of spending, but those are for 3 reusable tools that we use for multiple productions. And then for every build we've done so far, it has had a 100% success rate in us completing it successfully. And then this is just the visual of all the coding we had for the Arduino.
So as for the subsystems, our two main subsystems that we used for testing was the ultrasonic sensor and the piezo buzzer. The main parts of our entire product will be whether or not the ultrasonic sensor can pick up an object in front of the user, and then the piezo buzzer is the way to uh, audio give audio feedback as to whether or not they need to move left or right. And for this one specifically, we tested the sensor itself. The piezo buzzer was just used as a way to uh, know whether or not it actually worked. So if it beeped twice within a short range and beeped once within the farther ranges. And for testing, we had to, as previously stated, mark out the 1 foot, 2 foot, and 5 feet distances. So we placed a small box in front of the sensor and see whether or not the correct amount of beeps happened in response to it. A few things we had to redo each time is whether or not it continued going even when the box was removed. So because of all the mess you can see behind, there were a few tools and extra objects that were sitting in the way of the sensor. So we had to redo the test and see if we cleared out entire space.
Board. 3, 2, 1. Okay, so now we're moving on to test procedure. So how we started? We started with distance of from 0 feet to 1 feet. And from this range, the buzzer was successful and beeped twice. And this is yet repeatable. Distance from 2 to 5, when we moved it up a bit, the buzzer did a little something different. It only beeped once. However, this is still repeatable. Distance from 5 feet or greater. And it seems that the sensor is detecting things that are greater than 5 feet. And the box in picture was at the maximum distance. So it's a little farther than 5 feet. and any farther than that box that we have in the picture, it wouldn't beep. That is easy problem to fix. We just gotta go into code and adjust the max distance. And although this is not an accurate result that we're looking for, is a precise result, and it is repeatable.
As for testing, the sensor had an 88% accuracy rating. There was a significant dip at the 1 foot, but that was because of some human error. So having to manually measure out feet on a string definitely held back the accuracy of it. And the accuracy itself was determined to in between 0 and 1, the buzzer should have beeped twice, and and anything higher than that, it should have been 1 beep. Anything higher than 5 feet, it should have stopped completely. But you can see that it significantly dropped at 5+ feet because the maximum range was not set to 5 feet, it was set to 5 feet and 4 inches.
All right. And then for the ultrasonic sensor, the vision cone of it was 15 degrees. And so for that, we used the formula visual angle in radians equals 2 arctan of the base length divided by 2 times the distance, which is how we used to calculate the average area covered by the base length when using the ultrasonic sensor. So we can find out the best distance to measure things with. And at about 5 feet, the length was about 1.3 feet, which created a large circle to detect objects in front of the user. And we decided that was good enough. So we stuck with 5 feet for around the largest length would go.
And for the analysis or expert input was that the sensor needed to be straight to fix any measurements that would get messed up. And we also need small adjustments to the code that would make sure that our range measurements were correct. And to make those corrections, we attaching the sensor to the glasses will make sure that the sensor stays straight. Using a tape measure, we'll make sure that our distances are accurate. And if all the data is collected at success or measurements are a little off, but those are easily fixable by adjusting the code and having final frame for the sensor.
Thank you. Here's our email. Any questions that you may have, do ask them. We will try to reply to them as well as we can.